All right. Okay, so here we go with arithmetic sequences. Our objective here is to write a formula for the nth term of the arithmetic or geometric sequence given the value of several other terms. And we're going to use this to help us find different other values with the formulas and see some other similarities. So anyways, moving on. Vocabulary. What are we going to look at here? We're going to hear about sequence, terms of the sequence, arithmetic sequence, and the common difference. Okay, so if we do this, now a sequence is basically, and I'm going to speed this up a wee bit, is a set of numbers which are called the terms of the sequence in a specific order. For example, let's look at this little buddy right here. Here you can see, notice that the distance is changing by 400 each time. Time is changing by 132 every single time. So they're adding a minute and 32 seconds every single time for every 400 meters in distance. This is similar to what we were talking about with slope and linear functions, but here we're talking about with arithmetic sequences, we want to see that there's a common change here, just like we do with linear functions. When the difference between terms is the same, then we have what is called an arithmetic sequence. Linear function. Keep that in mind. And that difference is called the constant difference. So we want to see that the change is always the same and that this would all be like that. Okay, so an arithmetic sequence, we're assuming that they all change the same. For example, okay, so first examples, determine if the following is an arithmetic sequence. Well, to go from -4 to -2, I'm going up 2. Then from -2 to 0, I'm going up 2. Then from 0 to 2, I'm going up 2. So guess what? It's an arithmetic sequence. Yes, it is, with a common difference of 2. Okay, how about this next one? 1, 4, I've got to speed this up. 5, 25. Here I can see 3, 5, and then, what, 16? Guess what? Those didn't change the same, so not an arithmetic sequence. Moving on. What about fractions? Yes, you can do fractions. What? You can do fractions? Yes, you can do fractions. All right, so on the fractions, let's see. Subtract. Use the calculator if you have to. 5/8 minus 1/2 is 1/8. 3/4 minus 5/8 is 1/8. 7/8 minus 3/4 is 1/8. So guess what? It's an arithmetic sequence with a common difference of 1/8. Guys, all you got to do is really kind of subtract, so it really shouldn't be that difficult. You can use a calculator and do most of the subtraction if need be. Okay, so now we want to find the next terms on a sequence. Okay, so let's go through those examples. So here I'm saying this is a sequence, an arithmetic sequence. Now find the next 3 terms. Well, here they're going down by 6. Notice it doesn't have to always go up. They can go down. So if I keep going down by 6, subtract 6, subtract 6, subtract 6, like that, I'll get -9, then -15, and then -21. That's it. What about this example? Well, they're going up by 1.5. So I can just keep adding 1.5 and I will get the next 3 terms. Now, sometimes that can be, let's say, annoying because you would run out of, like let's say if I asked for the 15th term. Well, you'd have to do that a lot of times to get there and keep track. So could there be an easier way of doing that? Well, we want to find the nth term. So let's start off with that. What that means is I want to be able to find the formula for doing this. Now, if I say the first term is A1, the second term is A2. So the second number is A2, which we get by saying A1 plus the difference. Third term is A3. That we can get easy by saying the first term plus 2 times the difference. So rather than say keep adding, we can start using multiplication because when you repeat adding, remember, multiplication is repeated addition. So we can go all the way like that, and eventually we can say, hey, look, if we keep looking for whatever number term you want, that's this, the formula would be A1, the first number, plus whatever term you're looking for minus 1. So like if I said the ninth term, I would say 9 minus 1, which is 8, times the difference. Okay, so how can we use that to find an example? Okay, so let's write I can't even read my thing. Write an equation for the nth term of an arithmetic sequence. So I have this arithmetic sequence, negative 12, negative 8, negative 4, and 0. Dot, dot, dot. Remember, dot, 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 those are called ellipses, and that means that it keeps going. It doesn't stop. It keeps going. All right, so this formula is what I'm going to use. Just that. You're only going to substitute into these two spaces. Right in there. That's it. So if I do that, okay, well the first number is it goes there. That's your A1, which means it would go first right there. Then I need to figure out the difference. Well, they're going up by 4. So that's a positive 4, so I'm going to put a 4 right there. You would like to be done, but you're not. Now we go back to what we did in the first 6 weeks. We want to simplify this, so we need to use distributive property. So I'm going to say 4 times n is 4n. 4 times a negative 1 is negative 4. Combine like terms, and I get negative 16 is equal to 4n. You could also say 4n minus 16, but I don't care. Whichever way would work for you. Now, with that, I could easily find, say, the ninth term. All I would have to do is I'm using this formula. I'm going to put, notice how I say A9, which now means I'm saying I want to find the ninth term. This is my answer for the ninth term. Answer for the ninth. Negative 16 plus 4 times 9. Notice I put the n there. Because I've already simplified this, I can do it like this. And the ninth term would be then negative 16 plus 36, which would be 20. So all I had to do was plug this in based on the formula I found here. So keep that in mind. Okay, then I think we want to say which term of the sequence gives you a different answer. Which term of the sequence is 32? In other words, when your answer is 32, how many terms did it take to get there? This becomes like solving an equation because I'm going to put the 32 in the A for n. Add, and then you can divide. That's all you got to do, or subtract, and then you can divide. But it's that simple. So basically, that right there tells me the 12th term is the answer, or the 12th term will give me an answer of 32. Graph. Well, let's see how it looks like when I graph. First 5 terms. These are my first 5 terms. I made a little table. Notice n, I'm treating as the x, and a to the n as my y. So I graph those. You will not connect these points, so leave them as points. But notice how they behave in a linear fashion. Okay, so final example, let's do the same thing. Let's find an equation using these terms. I should have put here question mark dot, or I'm sorry, comma, dot, dot, dot. Okay. So I'm going to use those terms, this formula. Okay, the first term is 3. The difference, you'll see, is negative 13, because I'm going down by 13. Distribute. So I'm going to distribute. Negative times a negative is positive. Combine like terms. So now I get positive 16 minus 13n. Then, whoopsie, went too far. Let's say I want you to find the 15th term. That means you're going to put 15 place of the n, and you would get an answer of 179. Or, which term gives me an answer of negative 114? I think it's negative 114. Oh, I was right, negative 114. So I plug that in, subtract, and then divide. And you would get positive 10. This answer should always be positive. Keep that in mind. That covers pretty much everything right there. If you do have any questions, I will try to go over some more examples a little bit tomorrow, and you will have an assignment on this. But that's pretty much it for today. Thank you very much.